Hello, I am Akray Mizgana, Applications Manager in Texas Instruments Position Sensing product line. In this video, we will show how to quickly set up and use the TMAG5173EVM, which is an evaluation module for the TMAG5173-Q1 I2C linear 3D Hall effect sensor. The TMAG5173-Q1 device is a low-power, linear Hall effect sensor with an I2C output interface that is for a wide range of automotive and industrial applications. This device integrates 3 independent Hall effect sensors in the X, Y, and Z axes, a precision analog signal chain along with integrated 12-bit analog to digital converter digitizes the measured analog magnetic field values. An integrated angle calculation engine, Cordic engine, on the TMAG5173 provides full 360 degrees angular position information for both on-axis and off-axis angle measurement topologies. The angle calculation is performed using 2 user-selected magnetic axes. The device features magnetic gain and offset correction to mitigate the impact of system mechanical error sources on this angle error. The device supports multiple power modes, including an active mode, sleep mode, and a wake up and sleep mode that automatically alternates between these 2 modes based on a selectable time interval. The TMAG5173 can also be configured to enable any combination of magnetic axes and temperature measurements. Multiple sensor conversion schemes and I2C reframes help optimize throughput and accuracy. The TMAG5173-Q1 is an AEC-Q100 qualified low-power linear 3D Hall effect sensor for automotive applications. In addition, this device is ASIL-B functional safety compliant, making it suitable for functional safe system designs. EVM for this device includes the following features. GUI support to read and write device registers, as well as view and save measurement results. A 3D printed joystick module with embedded magnet to facilitate magnetic measurement evaluation with the TMAG5173. An EVM for custom use cases, and it is conveniently powered from a common micro USB connector. The EVM kit comes with 1 PCB, 1 standalone magnet, and the 3D printed joystick module, which has an internal magnet. This EVM connects to the GUI through a TI sensor controller board, or TI-SCB, which is sold separately. For evaluation, 2 PCBs are needed. The first of 2 PCBs is the TMAG5173EVM, which is shown in this picture. This PCB has 2 independent halves. The left half evaluates the A1 device variant for the TMAG5173, which has 40 and 80 millitesla sensitivity options, while the right half evaluates the A2 device variant, which has 133 and 266 millitesla sensitivity options. The 2 device variants on the board can be evaluated with the PCB intact as 1 unit, as shown in the picture, or can be split in half by gently flexing the panel at the red line in the picture so that there are 2 separate boards for the TMAG5173A1 and TMAG5273A2 portions of the original board. The second board is the SCB, which is sold separately. The SCB, which communicates to your computer via USB, is connected to either the A1 part of the board or the A2 part of the board. To install the drivers, the SCB can then be connected to either the A1 or A2 parts of the EVM, which will be shown in this video. Here we will show how to evaluate the A1 part of the board with the joystick module. To do this, we connect header J1_A1 of the EVM to header J1 of the SCB as shown. We then connect the joystick module to the A1 part of the board. To connect this, the prongs of the module are applied from underneath the EVM until they lock to the 2 holes as shown here. Next, The SCB is connected to the PC using the micro USB cable. When it is connected to the PC, the green LED near the USB receptacle turns on to let you know that the SCB is now powered. We are now ready to launch the GUI, which can be launched from the link in the user's guide or the link on the EVM page. After clicking on the link, click on the box that says TMAG5173EVM_GUI. Next, close out of this dialog box. For the first time use, you may need to install additional drivers for the TI Cloud Agent installation. If these additional drivers are needed, the GUI screen will direct you how to install these drivers. After completing these steps, confirm the SCB has connected properly. You will see hardware connected in the bottom left corner of the GUI interface if the SCB has been connected. If connected properly, click on the Register Map tab of the GUI. This page configures the register settings for the TMAG5173 device that is connected. For this demo, we will measure the magnetic flux density of the X and Y axes that are produced by the magnet that is integrated in the joystick module. To do this, we first click on the device config to register. And then we verify the drop-down box for the operating mode. It says that it's in standby mode. And that the drop-down box for trigger mode register bit says start at I2C command bits. After verifying this, click on the sensor config 1 register. Make sure that the X and Y channels are enabled in the MAG channel enable. You can also select enabling the Z channel, but only the X and Y channels are required to observe the effect of the motion of the joystick. In this case, we'll enable the Z channel in addition to the X and Y channels. Next, click on the sensor config to register. Set the XY range drop-down box to the desired magnetic flux density range option. For the A1 device, option 1 selects the 40 millitesla range, and option 2 selects the 80 millitesla range. If the A2 device was connected here instead of the A1 device, option 1 would select 133 millitesla range, and option 2 would select the 266 millitesla range. Since we are using the A1 device and the joystick module has a magnitude that is less than 40 millitesla, option 1 is the best option for full-scale output range. If the Z channel is enabled, please note that this channel sees larger fields than the X and Y channels. As a result, you should select the 80 millitesla option. This will ensure that the Z range bit in the sensor config to register is at the appropriate value so that the Z channel will be able to sense the magnetic field created in the Z direction. To view the magnetic field generated by the joystick, go to the Results Data page and then to the Plots tab. Ensure that at least the X component and the Y component checkboxes are selected on the Results to Collect Show box. Then press the Collect Data button. Now we will see the joystick module in action. Due to part-to-part variation and magnet alignment errors, the results may vary from device to device, which is typically dealt with by doing system calibration. In this demo, we first observe the X and Y readings when the joystick is moved to the left. moving the joystick to the left causes an increase in the X component of the magnetic field. You also see a small change in the Y component here due to the Y position also slightly moving when trying to move the joystick to the left. Next, we move it to the right. And we notice a decrease in the X component. Then we move the joystick up, and we see an increase in the Y component of the magnetic field. Finally, we move the joystick down and see a decrease of the Y field. After testing the A1, the A2 part of the board can be tested by first exiting the GUI, disconnecting the SEB's USB connection, disconnecting the A1 part of the EVM from the SEB and joystick module. A similar process as before can then be done to connect the A2 part of the board to the SEB by connecting J1 A2 of the EVM to the J1 header of the SEB. And the joystick module will then get connected to the A2 part of the board, as shown here. As an alternative to the joystick module, this EVM can also be tested by bringing the standalone magnet that comes in this EVM kit or your own magnet near the 5173 EVM to observe the change in magnetic flux density reading. The small form factor of the EVM also enables integrating the EVM in your system for further testing. In addition, if it is desired to test the angle measurement functionality of the device, for on-axis applications, the TMAG5173 EVM can be purchased. The 5273 EVM has a rotate and push module for angle sensing instead of the joystick 3D printed attachment that comes with the 5173 EVM. The rotate and push module on the 5273 EVM can work with either the 5173 EVM or the 5273 EVM. For more information on the capabilities of this EVM, please visit the TMAG5173 EVM User's Guide. If you would like to learn more about our Hall Effect sensor portfolio, please visit ti.com/halleffect to explore our technical resources and products.